For years now, people have stared at Lake Mead as the water keeps dropping, and they've traded stories about what's down there. Sunken boats, a World War II bomber. Some folks even swear the old bulldozers from the Hoover Dam construction are still resting on the bottom. So we checked. The bulldozers are a myth. There's no fleet of caterpillars sitting under that lake. But there is one machine down there. A machine the size of 2 football fields. And the strangest part is how it got there. Nobody dropped it. Nobody lost it. It dug its own way in, 600 feet under the desert, and the front of it was never meant to come back out. This is the story of the third straw. By the year 2000, Lake Mead sat near full. 20-some years later, it had lost over 150 feet of elevation, and Las Vegas had a problem most cities never have to think about. Roughly 90% of the water for 2.5 million people comes from this one reservoir, pulled through intake pipes near the surface. Intake number 1 sits up around 1,100 feet of elevation. Intake number 2 sits a little lower, and the lake kept falling toward both of them. If the surface dropped past those pipes, the pumps would suck air, and the fastest-growing city in America would go dry. So the Southern Nevada Water Authority decided to build a third intake, not higher up the shoreline, lower. They would tunnel 3 miles under the lakebed and pull water from the very bottom at 860 feet of elevation, almost 200 feet below the oldest intake. They called it Intake Number 3. Everyone else just called it the third straw. To dig it, they ordered a custom machine from Herrenknecht in Germany. It was a dual-mode tunnel boring machine, factory number S-502, built in 17 months, shipped across the ocean in 5 pieces, then trucked to the Nevada desert in 61 separate loads. 600 feet long, 1,500 tons, with a rotating cutting head 23 feet across. It cost $25 million on its own, and before it could dig a single foot of the real tunnel, the project nearly died. If you want to see how the crews beat what happened next, hit like, and subscribe. In the summer of 2010, before the big machine even started, crews were hand-digging a starter cavern at the bottom of the access shaft. On July 1st, they cut into a hidden fault zone in the rock. Water and debris blew in faster than the grout could hold it back, and within days, the starter tunnel filled with muck. Then it happened again in October. Then a third time on the final shift of the year. Project manager Jim Nickerson called it an ancient fault in the rock. Mark Jensen, the Water Authority's director of engineering, put it plainly. They were fortunate no one was hurt, but the inflow buried equipment and made a mess of the whole starter tunnel. 3 floods in 6 months. So the crews gave up on that path entirely. They abandoned the original starter tunnel and cut a brand new one on a different heading, angling northeast and climbing half a degree uphill, just to sidestep the fault. The setback added more than 2 years and almost $40 million, and the giant machine sat crated on the surface the whole time, waiting. Then, in December of 2011, they finally lowered S-502 down the 600-foot shaft and pointed it at the mountain of rock between the desert and the deepest point of the lake. And almost immediately, the machine ran into the thing it was built to fear: water pressure. Here is the number that reframes the whole job. As the tunnel ran deeper under the lake, the water pushing back on the face of the machine climbed to 15 bar. That's roughly 220 pounds per square inch, pressing against the cutting head every second of every day. No tunnel boring machine had ever advanced under that much pressure. The previous record, 11 bar, was held by another Herrenknecht machine in Sweden. S-502 broke it. Werner Berger, the chief engineer at Herrenknecht, said they had configured the Las Vegas machine so that in addition to Plan A, you also needed a Plan B and even a Plan C, and they used every one of them. The machine was designed to spend maybe 30% of the drive in closed mode, sealed up and holding back pressurized water at the face. It ended up spending closer to 60% that way, double what anyone planned. The crews were tunneling through rock that leaked up to 3,000 gallons a minute. In some stretches, the groundwater was warm, heated by volcanic features nobody could see, and it carried so much dissolved calcium that small stalactites started forming on the tunnel walls. Inside, a brand new tunnel, like a cave that was aging decades every week. Then, a little over a quarter-mile in, the machine started eating itself. The entire center of the cutting head wore down. Not the rock, the steel. About 8 inches of solid metal ground away until the middle of the head had chewed into itself. The crews had to stop, hand dig a pocket in front of the face by hand, divert the water down to the floor of the tunnel, and rebuild the cutting head in place using induction heating, with Herrenknecht technicians flown in to run the repair. 600 feet underground, under a lake, holding back the pressure the whole time. The machine carried one more trick that sounds like something off a deep-sea oil rig. It was rigged for saturation diving. A sealed, pressurized passage ran from a living chamber at the surface through the whole length of the machine to a lock right behind the cutting head, so that workers could live under pressure for days at a time to make repairs at the face. Decompressing. From that kind of pressure would take about 5.5 days, no matter how long the work took. They bought the transfer shuttle for it. In the end, they never had to use it, but it was there, just in case the lake won. Before we keep going, like and subscribe. It tells us these engineering stories are worth telling. Now, while the machine clawed forward, something else was already waiting for it at the finish line, sitting on the bottom of the lake. Back in 2012, crews had built a massive concrete intake structure on a floating barge, towed it out over the deepest point, and sank it to the lake bed under about 300 feet of water. It weighed over 1,200 tons. To carve a flat seat for it on the lake bottom, divers set off around 23,000 shaped charges, a few dozen at a time, behind a curtain of air bubbles to soften the blast. Then they lowered the structure on cables over roughly 60 hours and locked it down with a continuous concrete pour that ran for 12 straight days. That concrete structure was the target. The machine wasn't just digging a tunnel. It was aiming, blind, through 3 miles of rock, at a docking ring sitting on the floor of the lake. And the people who built it had done something clever. The wall the machine had to punch through wasn't reinforced with steel. It was reinforced with fiberglass, soft enough for the cutting head to chew straight through without wrecking itself. On December 10, 2014, a minute before noon, S-502 finished the drive, and it hit that target in the bottom of the lake within about 2 or 3 millimeters. Nickerson said it missed by 2 millimeters on one side and 3 millimeters on the other. After 3 miles underground, under record water pressure, through floods and a self-destructing cutting head, the machine arrived almost perfectly dead center. Crews measured less than 20 gallons a minute seeping in around the shield. The contingency plans, the freezing, the grouting, the saturation divers, none of it was needed. And then they made a decision that is the whole reason we are standing here. They did not pull the machine back out the way it came, not the front of it. Crews welded steel plates between the machine's shield and the concrete structure, pumped grout into the gap to seal it forever, and left the cutting head and the front shield right where they stopped, permanently entombed in concrete on the floor of Lake Mead. They stripped out the back half of the machine, the motors and the gantries, hauled the pieces 3 miles back through the tunnel and up the shaft, and shipped most of it home to Germany. But the face of S-502 is still down there. It will be down there long after every one of us is gone. This job was not free, and it was not only measured in dollars. The intake tunnel itself cost about $817 million. The full system, with the deep pumping station built alongside it, ran to roughly $1.5 billion. But on June 11, 2012, a 44-year-old tunnel worker named Thomas Albert Turner from Henderson, Nevada, was killed underground. A concrete lining segment shifted about 4 inches, opened a small gap, and released a jet of pressurized grout and rock that struck him. He was a father of 2 who had been tunneling since the 1990s, and his brother worked the same project. Federal investigators did not cite the contractor, because the failure was something that had never happened on a job like this before. The crews marked his memory with stickers on their hard hats and kept digging the tunnel he died building. Today, the water is still falling. As of this spring, Lake Mead sits around 1,048 feet, near its lowest level ever, and intake number 1 has already been shut off. But the city is still drinking, because 3 miles out and 600 feet down, the third straw is pulling water from the very bottom of the lake. And the machine that made it possible is sealed into the lakebed, facing the rock it spent 3 years fighting. So the next time someone tells you there are old bulldozers hiding under Lake Mead, you can tell them the truth. We checked. There aren't. But there's something stranger down there. A machine that dug its own grave, on purpose, so a city could keep its water. If a story like this is worth remembering, like and subscribe, and tell us in the comments where you're watching from.